Is the capacitor a linear circuit element? A tricky question for many, as you can see from the results of the poll I recently posted. After thousands and thousands of votes, it was almost a 50-50 draw, believe it or not. The first thing we need to ask ourselves is, what is the voltage-current relationship for the capacitor? If you've been watching my videos, you should know that this is IC, the current, or the displacement current to be precise, is equal to the capacitance times the derivative of voltage. For this relationship to be linear, it needs to satisfy two conditions. The first one is superposition. For a sum of voltages, the current should be the sum of the individual currents due to each voltage alone. The second condition is homogeneity, meaning that if we scale the voltage by a constant factor, then the current must be scaled by the same factor. How can we check for these two conditions? Say we have a voltage V1 for which the output is I1, and a voltage V2 for which the output is I2. Say there is a third voltage, which is a linear combination of the two voltages, some constant A times V1 plus some constant B times V2. For the capacitor to be linear, the question is, will the output I3 be the same linear combination of the two individual outputs? Will it be A times I1 plus B times I2? Let's check this. I3, of course, is C times dV3 by dt. V3 is the linear combination of V1 and V2. And now, the derivative is a linear term, meaning we can expand and have the derivative of AV1 plus the derivative of BV2. Constants can be taken outside the derivative operator, so we can take the A and the B to the front. And now we can expand. And notice that the red part is precisely I1, and the blue part is I2. So I3 is indeed AI1 plus BI2. So it turns out that the capacitor is linear. This is not intuitive for many people, I know, because if you were to look at a graph of I versus V, you would not get a straight line by any means. But what if you plot a graph of I versus the derivative of V? Then you will indeed get a straight line whose slope is the capacitance, as we know from the equation. So yes, the capacitor is a linear circuit element. However, this is only the case in ideal circuit theory. The capacitor can actually exhibit nonlinear behavior due to some factors like breakdown at high voltages, parasitic effects and leakage current, and other factors. But in the ideal case, and in most practical applications, this is negligible, so the capacitor is indeed considered to be a linear element.